Do you catching the breakpoint?
What's this?
Do you know where you stopped?
Ish. I'll see here in a second. Let's see. Hide floating meeting controls. All right, you can see my screen, right?
Yeah.
All right, well, let's see if this sticks for now. So the parts at bucket start pause, if that guy is equal to do math, then we want to say op count plus plus. And then ultimately keep collecting our string. So string, we'll call this guy results. Start that off as the empty string. So we'll say result. Well, this is fine. We'll say results plus equals. And actually what I'm going to do, let me just go from start pause.
I mean, no matter what it is, you always need to.
I need to loop.
Add.
So while.
I think he.
Again.
Oh.
Yeah.
It's connected again. I guess you are right. Okay.
Can you guys still hear me?
Okay.
That doesn't seem good that it shut down again, then it came right back up. Can you still hear me now?
We can
Yeah,
hear
you are
now.
connected with the hotspot.
No, not yet. If it goes down again, I'll switch over to a hotspot. Oh. Something's not right with that. All right, so really what I want to do is I want to have my start pause. So while start pause is technically less than the parts dot length, I am sharing this, right? Nope.
Can you sharing the screen?
Loading meeting controls. All right, so I'm going to potentially go through all of the things in my parts array, although I happen to know that I'm not going to go all the way through it because, well, I might if my start pauses if I'm dealing with the right half. So this is fine. Now we're going to always say start pause plus plus here at the bottom to move forward. If I'm looking at a do math, I want to increment my op count. Else if I'm looking at an operator. So let's go this route. So I want to ask the question, if the thing I'm looking at, the part I'm looking at is any one of my math operators. So what I'm actually going to do is I'm going to create another private static Boolean is math op. This guy will take in a string as a parameter. And we'll go ahead and say s is equal to s dot trim, just in case, let's say. Then we'll ask the question if s dot equals plus, actually I could probably do
Index of.
Yeah, but I'd have to do it for each.
Well, you just put it all together as a string.
I'll do this. Plus minus times divide
not,
on
not,
dot index of, and then I'll pass this guy S. And if that guy is equal, I want to return true if it's in there. So we'll
oh,
say
greater than,
greater than,
greater than equal than, okay.
and then I can return this. Even put the trim in there. So this will return, here's all my math operators right now, dot index of. If it gives me something greater than -1, that means it was found in there, which means it is a math operator, so I'll return true. If it gives me something that's equal to -1, that means it's not a math operator. It'll give me a Boolean false. So now I can ask if something is a math op. So I'll say parser dot is math op, and I'm going to give it the parts at bucket start pause. If that's a true statement, then I want to say if op count is equal to, we can actually go ahead and reduce it now. We could say op count minus there, because it's definitely going to decrease. We'll see if op count is now equal to 0. That means we're done. We'll go ahead and return result as of right now. So if we kind of follow through this, op count is 1. Now op count is 2. So I've captured all this. I've captured this. I've captured this. I hit an operator. What did I do? I decremented op count. Is it equal to 0? No, it's only a 1 right now. So I'll keep collecting. Then I hit another operator. Now it'll be a 0, and I'll return everything I've collected up to that point. And what I'll actually do is, let's say return result dot trim. Else. We'll say result plus equals this guy, and I'll put a space after it. I do that up here. Okay. If it's equal to do math, and actually I can do this all the time. So if it's a do math, that changes op count, but we still will add it to our result. If it's a math op, that might change. Well, it will definitely change op count, and it might be the end of our thing. Regardless, we want to tack on to our result the thing we just ran into with a space afterwards and increment start pause. So this guy should be able to now give us a the math expression string for a given start pause. And this is for the parts. I really have to remember where the start pause was in this. So what I'm actually going to do, I want to give myself that position, because start pause. So whenever I return my result, I also need to know where the current position of start pause is, so I know where the next math expression is picking up. So really, I need this guy to give me a more complex result. So I can do that in the form of, I can make an object for this, or since I just need 2 values, I can go ahead and do it with strings. So when I return my result, what I'll actually do is I'll return the result concatenated with start pause. So add start pause to the end of the string, just so I can use it outside of this. Now, outside this while loop, I expect that I will have finished this. So I'll go ahead. Go ahead.
I have a suggestion. You can only return the start pause because between do match and the start pause, it is the left string, and the on the all the right hand is the right string.
Well, okay. So so you're saying if I return start pause, that means I can go ahead and put together all my parts in the other thing rather than return a string?
Yeah.
All right. So that's fine. So I can say where it ended at, and then that'll allow me to return start pause. I mean, we're going to get the same values either way. So one way or another, we're going to return start pause. We're either going to return it early or we'll return it at the very end, which means it's everything up to that point from the point that we originally started at. So that means I'm not building up a string here then. So I won't have this part. I'm just kind of figuring out where the last position is. So get do math expression and bucket, something like that. That's what this guy will ultimately do, and he'll return an int. So then inside here, I'm asking a question if it starts with a do math. So we can actually do both parts in so I want to send it the parts. So say parser dot this guy, and we're going to give it my current starting position, which for the left, we have a string expression. So my starting position initially will be, I guess, let's assume 0. And then we'll pass it the parts. And this guy is ultimately going to return a pause. And this will be the position within this guy, within the parts, where the do math ended. So pause is the position in the parts where the do math is complete for the left side. That's what pause will be equal to. So that means that I can go ahead and do parse math on that guy getting that do math expression, knowing that those particular things might, doing those particular things might ultimately give me a different value, right? Because if I have this, I'm seeing a do math, so I'll go ahead and say I'm going to pass in bucket 0. And then because that's where I'm starting, it's going to say, oh, the actual starting place or ending place is a 0, 1, 2, 3, 4. Bucket 4 was the last position in that. So that means everything from bucket 1 to 4 is my next math expression. And what do I do with math expressions? I parse them, and they give me a do math expression. That's what these guys ultimately give me. So I'll go ahead and get that, but I'm at the end of the day, I'm going to end up with potentially a collection of math expressions that these guys need to get added to, right? My parser right now operates on a
left expression, math.
yeah, so the idea of a do math expression has now changed. Let me look at our do math expression.
It is fine.
That takes an expression and an expression. But this left could be a do math expression. So when I say get left, I'm going to get it as an expression. That's fine. So it could be another do math expression that has an expression on the left and an expression on the right. So that's fine. So back in my parser, this guy will ultimately return. So I need to get my left and right from this. So we'll say left is equal to, actually I need to build up my string from bucket 1 to bucket
Pause.
pause. I'll say string temp is equal to the empty string for int I is equal to 1, I is less than pause. Pause is going to be the last legal bucket, right? So we want to say less than or equal to pause. And then we'll say I plus plus, and we'll say temp plus equals
And plus space.
bucket I concatenated with the space. All right, so that'll build up temp, and then we'll go ahead and we will return.
Well, the left is
Well, actually, yeah, we're left is equal to parse do math.
yeah.
Left is equal to parser dot parse do math.
Well, you can just pass expression. It's cool. Well, right now it is definitely a do math, but
I'm passing it temp because this is the do math expression that I need it to do. The left-hand side is going to be the result of calling parser.parse do math on temp. This is the guy I just built, right?
Yep.
All right, so that's going to be it for the left side if we're dealing with a do math. So for the right side, I'm actually going to steal most of this. So now if I'm dealing with the right side, I'm going to pass it pause as my starting point. That is the end of my, let's see, that's the end of my left-hand side. So then I can say pause plus, because I should have an operator next, followed by my do math. And this, we want this to start on that do math. So +1 is my operator, +2 is my do math. So my second call to do math expression is going to tell it where to pick up, and that's going to be pause +2, because pause currently is the last bucket of the parts of my original, my left-hand side math expression or do math expression. Now I want to start with the right-hand side do math expression, which is going to come after the operator for my larger do math, and then after the well, I guess the right hand side would be +1 will get me to the operator, +2 will get me to the do math. That's why this is +2. Pause is the position of everything right before the operator. +1 gets me the operator, +2 gets me to the right hand side do math. So up here, I want to say if pause +2 is equal to do math. Pause +2 is the place after my operator in my do math. How do I know that? Because I found out where my left side ended. Now, what that means then is I need to have pause, I guess, equal something as I'm going through here. So we're going to start pause off.
Actually, pause should be 1.
at 1, and then we can use pause here. The parts at bucket pause is equal to do math. Actually, yeah, that's fine because we're inside of a single do math. So pause at bucket 1 would be the beginning of our left-hand side, which could be a do math. Pause might change in there. If pause doesn't change, then we'll just use the pause that we currently have. Then when we get down here, pause plus 2 would still be the right-hand side, the beginning of the right-hand side, whatever pause is. This was either a literal or a resolve expression on the left, in which case it's only going to bounce forward 1, or, well, it'll bounce forward 2 because we have the operator in the middle. So this is pause
plus 1.
1 for my operator. So my operator lives at pause plus 1, whatever pause is. If pause started off at 1, then pause plus 1 would be 2 if I have like 5 plus 3. But if I had some big math expression over here, it'll look like this.
And I will have a suggestion. You don't need to consider whether the right-hand side, if it's a do math, because anything that on the right is just expression, no matter it's literal or math.
So we could actually just call do math. Well, actually, hold on.
Anything after the pause.
Yeah, I could call do math expression on that regardless.
Yeah.
So
you can say past expression.
Right, because it's going to be some kind of expression.
Yeah.
But this does, I mean, I can still ask the question. If it's a do math expression, I'm going to do this. Otherwise, I'll call parse expressions. This is still going to work when I'm doing.
I can say it can be simplified because you don't need to consider what kind of it is.
Yeah, I get
anything after that pause, just the plus as a operator and an expression.
But let's see, parse expression takes in a string, right? So I would still need to build up everything past that.
Yeah.
So I would take a I don't think that actually will simplify it because right now I'm operating off an array of parts.
The fact is here, you don't need the pass to say get do math expression and bucket anymore, because the pass plus anything say pass plus 2 afterwards is an expression.
Right, that's true, but I'll still have to build up that string.
Well, so you only need the for loop. You don't need if.
Correct. I get what you're saying. So I still need to build up this string in order to pass it. So regardless of what I'm looking at, I'm going to have to. I'm going to steal this. I'll go ahead and. So that's going to get me everything to the right. But let's think about that.
So right now you should do is for.
No. I get what you're saying. I get what you're saying. I'm just thinking recursively if that is still going to do what I want it to do.
Then the right is pass dot pass do math temp.
And it'll just go all the way through.
Yeah. Because
I get it. So I want this for loop for everything from pause plus 2 to the end.
Yeah.
So then I'll build up temp and then I can just call.
Yeah, right equals to pass expression
For temp. So we'll say everything from pause +2 forward is the right half of our math expression, or do math expression.
You probably need to give another temp. Declare another string then.
Why? I already have the
because
first.
you use the temp on top.
But I only used it. I've already used it.
Okay.
I'm done using it. I don't know. I could just empty it back out.
Okay. That might be.
Oh, but where did I define it? I defined it inside of.
You need to
I
define
defined it inside of here. So really what I could do is I could just define it beforehand and just use it twice.
Yeah. You must you have yeah, you can delete that.
All right. So that'll be the right hand side, and then we'll go ahead and do our do math expression, passing it the left, the math op, and the right, and return that result, knowing that we would have done that recursively several times in there, at least potentially. So what does parse expression ultimately? So parse goes through, and that calls parse statement, which calls parse expression.
You can using control and the left click pass expression, it will jump into it.
Control left click.
Yeah, left click pass expression. Maybe it is command key, it depends on your OS.
Was it wanting me to type it?
So no, if you have hold control and left click any function, it will.
Oh, right. But I haven't found the function yet. Oh, I get it. I get it. I have it up here. This guy. Okay. So parse expression is going to take in whatever string I give it. It's going to split the stuff up. It's ultimately going to return
the value
expression from that. And what am I ultimately doing with that expression? From parse, that guy's coming from parse statement. We're adding it to our list of statements, which is a collection of, so if I go to my statement, this guy holds a statement type, a do math expression, holds a left and a right. Remember statement is going to have an expression as the right hand side, which is ultimately going to give us our single object that will have all the math in it.
Mm-hmm.
So I think this does what it needs to do for parse. So I just want to do parse display here. So we have a remember statement. E is an expression, do math. Expression, literal expression 10 plus another do math expression, literal expression 4 minus a do math expression. Resolve expression is the left for A plus another resolve expression for B. Is that what my
correct?
Yeah, 8 plus B is the last one. Okay, so now I'm parsing it out correctly and have all my pieces. So now we need to go and update our interpreter.
You don't need to do anything.
Well, I just want to at least let me look at my interpreter. because this is that process. We want to make sure that we go through that same pattern of update your syntax, update the parser, update the interpreter. So even if we ultimately don't do anything to the interpreter, we have to go through the process of looking through it and making sure we don't have to do anything to it. So let's confirm that, because I would not have necessarily guessed that, but let's see if the way we already wrote it just happens to function. So if I'm interpreting a do math expression, I get my left, that's my left value. So I get expression value from that. What does expression value give us? Well, I can use your trick here. Expression value says if it's an instance of resolve expression, do this. If it's an instance of literal expression, do this. If it's an instance of do math expression, do this. So there's our handling of that. So it already is written in such a way where the left hand is some expression and it's going to get the value of that expression. So that's where it already is doing the math for all of it. So what do I expect my answer to be here? Where's my syntax? So I want to, a plus b is 12, 4 minus 12 is -8, plus 10 is 2. I expect this to give me a 2.
You have to uncomment.
Comment. My own area variable b not found. Did I define it?
Interesting.
A is 5, b is 7. Just for a second, let me just take that line out. Make sure I get an A and a B. All right, so those are good. So now I'm saying, remember, int e is equal to do math 10 plus do math 4 minus do math a plus b. It looks like it's
Is it possible the execution sequence?
It's going from bottom up.
I'm guessing. Maybe
right.
Try to change it to do math a plus b and see if it's work or not. It's still working. I don't know why.
Well, here, let's just make it easy at first. So this is not using any variables. So there's our
okay, you forgot that maybe there's a string you need in the do math.
right. Ultimately, that's going to be because it was trying to, the variable was called b. So actually, we could probably parse it better instead of fixing it in here inside of our parser.
You should say do math.
Trim it.
Yeah. I think it's past.
It's probably where I'm building my temp.
Yeah. Here, yeah, this one you need the temp dot string, and the left also do string. Try it again.
There's our E9, and it's 9 because I changed up my syntax.
That's it, correct. 9 is correct.
So let's put it back to a plus b. This should give us a 2. Yep. All right, so there's our recursive calls for that, where we had to, through our parser, we could have done this doing just string manipulation rather than doing parts. But effectively what we did is whenever we hit a do math, we went and said, give me the left expression, whatever that is. If it's a literal expression like it is now, great. If it's a resolve expression, great. If it's another do math expression, that's fine too. So in this case, it returned the expression that is the left side, and it gave me the expression that is the right side. But in order to get the expression that is the right side, it had to call parse do math again, which found the left side was a literal expression and the right side was, oh, another do math expressions. Now it's saying, okay, call parse do math. Give me the left side, which was a resolve expression. Give me the right side, which was a resolve expression. So that was the, so we returned the expression for that, which became the right-hand side of the expression for this, which became the right-hand side of the expression for this. Does that make sense? And if we want to say do math 5 times 2, so we'll get the same answer here, but now the left-hand side is another do math. Array index out of bounds, 13 out of bounds for length. Do math 5 times 2. So this is when the left-hand side is a do math. So it has to be something in our parser on the left-hand side. What line was it complaining about? It's in parse do math line 83. So this guy right here. I want to make sure it should be less than or equal to pause. Because what are we returning for pause up here if we're on a right-hand side? Pause would be off the end. So if I'm the right-hand side, I finish building the entire thing here. So I actually want to return start pause plus 1 to give me the actual final position. Index 13. Let me take this out here for a second. So the issue here is, so it's complaining about an index 13. Let's just go in here. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And it's trying to get to bucket 13 of that. If it's the right-hand side. So the problem is only when is it returning our 13? Yeah, this is for the left. Parts at bucket I starts off at 1. But it actually should not start off at at 1. It should start off at start pause. Oh, this is parse do math. So this is always correct. Starting pause off at 1. But we're passing, this guy always takes in a string. That's what our temp is. That should be fine. Then we're splitting it. Pauses to do math.
How about just run the debugging inside the get do math expression and bucket?
Well, we already know what the problem is. This guy's becoming a 13. And it's when we're calculating the left.
I think the pause is larger than it should be.
Correct. But where is pause coming from? It's getting the get do math expression end bucket.
Yeah.
That's from this guy. We were just looking at it. So I return pause here and I return pause here. If I'm on the left-hand side, let's make sure pause isn't going 1 too big here. Start pause less than parts dot length. If start pauses do math, op count plus, else if it's a math op count minus. If op count is equal to 0, return start pause. And start pause currently would be the operator. This should actually be start pause plus 1. Oh, no. This should be start pause minus 1. The end of the left-hand side. Start pause is the operator. Start pause minus 1 is the end of the math expression right before the operator. Otherwise, if we go through the entire thing, we never actually hit an operator because we're on the right-hand side and we just return start pause. Still index 13. And that is in parse do math right here. It's saying I is becoming a 13. I mean, the obvious fix is that, but if I'm going up to and including, we're going to be missing a piece. Yeah. Is my syntax correct in here?
Oh, syntax is
For do math, this would be
1,
0, 1, 2, 3, 4, 5, 6, 7.
it is correct.
10, 11, 12. So this is bucket 12. I'm trying to do bucket 13, but why am I trying to do bucket 13?
So it means the do math, it didn't stop. It didn't stop at the equals to.
First expression.
It goes to the end. It goes to the end of while loop. So it's never reaching the
Oh, it's still incrementing start pause by 1 here at the end.
So it's until the while loop ends.
I need to return -1 there.
No, I think it's because something inside the if statement.
Which if statement here?
Yeah, it's never reaching the else if, so it's never return.
If it equals do math, increment
Operate.
op count. Else if it's a math op, do this.
1, 2. Can you just print the op count at the before the return?
I think op count is going to be correct. I don't think that's the problem.
Can you go up a little bit? Never mind, just stop here. 1, 2.
This is the operator. If I'm inside here,
1, 2 should be correct.
I do want to send the next one. Otherwise, we've captured everything.
Oh, wait a second. Now you are doing the. Oh, never mind. I still would like to say, can you just before the return start pause, add a system.out print op count? Oh,
It's not even getting to that line. I need to move it up.
so that is why I said it's never reaching the. I guess you still not reach. Oh, this one. Op count is close to 3. Why it's 3?
Parts is 13 buckets.
Maybe your parser is mass op is wrong. So your is mass op that is wrong. The syntax. Because it's reaching there, it means it's not 13 is empty.
No, it's not that third. This is telling me this is a 13 bucket string array.
Okay, but now right now the
Current
start
3. So
is,
it's looking at bucket 3
8.
here, and it's finding this guy to be a math operator.
Okay.
So then it's going to decrement op count. So where's my step over here? Where's my stuff?
It's
At the bottom.
it's on the right hand of the stop square.
Oh, I see it. So I'll go ahead and step over that. Op count should now be a 2. So we won't get into that if statement. Start pause goes up.
But
Start pause is a 4. And here I'm going to keep this expanded. So we're at 4, so that's a 2. It's not a math operator. So now we hit start pause is a 5. Bucket 5 is a plus. Not that, but it is this. So now op count goes to a 1. It's not a 0 yet. start pause plus plus, so we're at 6. 6 is a do math. So we should get into this first if statement. Op count's now at 2. So start pause is currently is 7. That's a 4, so we won't get inside of this. We won't get inside of this. So now we're at a 8, which is a minus. We won't get inside of this. We will get inside of this. So now it's a 2 became a 1 again. Start pause is now a 9, which is a do math. So op count will become plus plus. So now we're at a 2 again. Start pause plus plus. We're at a 10. There's my A. Oh, I think I see. I see what the deal is. So that's my A. It's not a do math. It's not a math op. So now I'm at an 11, which is a plus sign. Not a, so that'll take op count back down to a 1.
The initial op count should be 0.
Now I'm at start pause 12. 12 is my B. So it's going to skip both of these. Now I'm at a 13. Start pause is less than parts dot length. So we should be done now. This should fall
It
past
is
the little while loop. I'm returning the value of start pause, which is a 13. And this is in get do math expression. And
the op count should be 0, the initial one.
the reason I chose it as a 1 is because my start pause automatically assumes I'm past the first one.
But actually, if you go from 0, then that is 1. Because you escape the first do math.
I see. I see. So I was never getting down to 0 with it.
Yeah.
Let me make sure that I can do math. Do math 2 plus 3. Yep, still 2. So when I first called it, I was already counting this as my 1 for op count. But then I was doing it again, which gave it a 2 too early.
You start from the second do math, but that is why the op count actually will never reaching.
Right, because I'm looking for the end of this guy.
Yeah.
So my op count needs to be relative to this guy.
Yeah.
Yeah, I got it. I originally had it as a 1 because I was already counting the op for this guy. Interesting. Okay, so I think that is a version of the homework, right?
Yeah.
How do I get out of debug here? I just pull that. Does that take me back? Let's just say that's good. Okay, so now we can handle syntax that works with kind of recursively specified do maths like this. So what would be the next feature? Remember, our language we're trying to represent is, should have memory, which we have the ability to do now. It should have the ability to ask questions, right? So now I should be able to ask a question, maybe with, so something along the lines of maybe question E greater than 0, something like that. And then maybe we say do let's say remember C is int, sorry, remember int C equals 1, otherwise remember int C is equal to 2, something like that. So we should be able to ask a question. The syntax for a question is a Boolean expression followed by the word do, followed by the statement we execute if we are part of this. And our initial version of our question is just going to allow for a single statement. And I say the initial version, that's actually true of even modern languages like Java. If I look at a loop in Java, a good one will be inside of our parser here. So here's a while loop. That is a single statement, what I have highlighted. It just happens to be called a block statement. And a block statement is a collection of other statements, but it's still a single statement. So that's why when you maybe first learn about loops, they say, oh, the curly braces aren't required. Well, they're not required if you're only going to have a single statement under the while loop. Like single statement, like maybe like op count plus plus. If you're just going to have that underneath the while loop, you don't need the curly braces, but the curly braces are never incorrect. And with this, you can now say, I have a collection of statements I want to run as part of this while loop. So in order for us to support this, we're going to have to build a new kind of statement. We're not going to do that yet. What we're going to do initially is assume that we're not writing a loop yet, we're writing just an if statement. Assume that our if statements, our conditionals, the questions we're asking, assume that those guys always have a single statement as the what happens in the true expression versus false expression. And if I wanted to go and add that to my interpreter README, where's this guy, we're going to add a new kind of statement called a question statement. A question is going to take in a Boolean expression. So we're going to need a kind of expression that boils down to true or false. Okay, and right now we're going to say Boolean. Well, we'll actually go down here with our operators here in a second. So we're going to have a question that is a Boolean expression, and then we're going to have the true statement. Let's see, do true statement, otherwise false statement. So that's going to be the syntax for our question, where a Boolean expression is any expression that boils down to true or false. All right, so I'll put something, well, I don't know, we'll just leave it like that. So that's going to be our syntax for a question. Now we're also going to have a new kind of expression. So maybe this expression is, and let me go in here just to, So right now I'm doing this expression like this, but this is a new type of expression for us. So what I'm going to do is I'm going to call this a test expression. So we're going to test E greater than 0, and that's going to give us a result. So back in my syntax, so we're going to now add a test expression, where this is going to be a expression followed by a arithmetic Boolean op followed by an expression. And this guy should have semicolon at the end of it because it's a statement. This guy should have a semicolon at the end of it because it's a statement. All right, so now we have a new kind of expression called a test expression, where a test expression takes in an expression, an arithmetic Boolean operator, and another expression. And it boils down to true or false. Now, technically, we now support another type in our language called a Boolean. We're not going to have to do anything special for that yet because we're only ever using Booleans as part of a test expression for right now. But we will probably want to expand our remember statement to support remembering things other than integers eventually, but not necessarily yet. Let's just get a basic if statement working. So we will have another type called a Boolean. Now we have our math ops, and then we're going to have our arithmetic Boolean operators. And these guys will be greater than or equal to, less than or equal to, not equal to. Do something like that. We'll just stick with our syntax we're familiar with. So these are our arithmetic Boolean operators that allow us to check to see if one number is less than, like greater than or equal to, less than or equal to, or not equal to another number, or any expression is our question. So it's a Boolean expression is going to be a result of a test expression. So we can actually probably say a test expression here, since that's the only way for us to produce a Boolean right now. What to do if it's true, otherwise what to do if it's false. All right, so the homework, I'll go ahead and put it into a slide here. Oh, that's not it. Homework is add the ability to ask questions to our interpreter. So this is going to come in the form of add a question statement, add a test expression, implement parse for both of these, implement interpret for both of these. In the end, a statement like this should work. whereby our example over here, if E was a 2, then 2 greater than 0, if that's a true statement, which in this case it is, 2 is greater than 0, then I want to add a new variable to my environment C that's equal to 1. Otherwise, so the result of this particular question would be a new variable being added, C equals to 1. Otherwise, I'm going to set a new variable C is equal to 2. Okay, so if I change this to say E less than 0, or in this case, E is currently 2, now it would be false, so we would get a C is equal to 2 as our result. This is a question statement. All right, questions about this? Make sense what I'm asking you to do? That's a GitHub link and the self eval. And then, so I don't forget, let me go ahead and push the latest version of this guy. Get them. Added do math recursive. Push that to Oregon. All right, so now you should have the latest version of the interpreter. All right, so what questions do you have for me ahead of being able to do this assignment? Or are we just good to go? Okay, well, so let me put this up on Blackboard. So this is homework 7. No. Okay. And this will be due on Monday at 10 a.m. All right, questions, comments, concerns, bribes? All right, I will see everybody on Monday then.
See you.
Take care.
Have a good day.
Yep.